All right, today's lesson involves applying all the different things we know about parallelograms and turning it around and saying, this is what makes a parallelogram. So if we have both pairs of opposite sides congruent, then our figure will end up being a parallelogram. If we have consecutive angles, if all the consecutive angles are supplementary, then our figure will end up being a parallelogram. If both pairs of opposite angles are congruent, then our figure will wind up being a parallelogram. I'm going to skip ahead here. If the diagonals bisect each other, then our figure will end up being a parallelogram. Now here's the new one that we haven't really covered. We might do a proof on this as one of our homework problems. If one pair of opposite sides, and it doesn't matter which pair, but if one pair of opposite sides is both congruent and parallel at the same time, if they have the same length and they're parallel, then your quadrilateral is a parallelogram. And then finally, the definition of a parallelogram, if both pairs of opposite sides are parallel, it's a parallelogram. But that was our definition. All right, so we've got basically 5 ways in the definition to prove that something's a parallelogram. How are we going to process this? What are we going to do with that knowledge? Well, the first thing we can do is we can solve problems based on knowing that something is a parallelogram, or that we want to make sure that something is a parallelogram. So in this case, this question is saying, what would the value of y have to be for this figure to be a parallelogram? Well, right off the bat, we know what about parallelograms? Yeah, the opposite sides are congruent. So basically, the geometry of this question is PQ is equal to SR, and that PS is equal to QR. And then when I start to plug stuff in, 3x minus 5 is equal to 2x plus 1. This is great, because in this equation, what do I only have one of? The variable. I only have one variable type to deal with. So I can just straight up solve this mug. So I'll subtract 2x from both sides and get x minus 5 equal 1. I'll add 5 to both sides, and x turns out to be 6. Now, if this is going to be a parallelogram, is there any other value that x could be? No, because if I make x any other value, then these two won't equal each other anymore. So x has to be 6. Knowing that x is 6, x plus 2 is equal to y. So 6 plus 2 is equal to 8. So the answer to the question is y is equal to 8. Y has to be 8 to be able to do this problem. To be able to say for sure that this figure is a parallelogram. Because it can't be a parallelogram without the opposite sides being congruent. Both pairs of opposite sides being congruent. Everybody okay with that? Any questions about what I did? All right. So I'm going to jump way ahead here to the ways to prove a quad is a parallelogram. You might want to go ahead and jot these down real quick. You can jot them down when you get home if you want to. But we're going to be using this information. So something you can see right now that you'll be able to use as we work through the rest of the stuff in the class. Go ahead and jot these 6 things down. Right now, go ahead and work with your partner and solve this one. Find the values of x and y that will force this to be a parallelogram. You might want to look at your 6 rules. Let's take a look at what we do here. Now, the first thing I probably would have thought about doing was setting the opposite angles congruent, because in a parallelogram, opposite angles are congruent. So when I do that, I get 3y minus 2 is equal to 12x plus 7, and then over here I get y plus 10 is equal to 4x plus 13. So I'll probably solve this one for y. So y is equal to 4x plus 3. But then something weird happens when I go and substitute it in over here. 4x plus 3 minus 2 equal 12x plus 7. I distribute and I get 12x plus 9 minus 2. Simplify and I get 12x plus 7. This is going to be a problem because when you're looking at a system of equations and your system of equations ends up being the reflexive property, that means there are infinitely many solutions that would work for this. I can't narrow this answer down to one solution because if I subtract 12x from both sides, I'm left with no variable and 7 equals 7, which is a true statement. So basically it means that the system that I'm using here, the pair of lines that I would be using, are parallel lines. So it's not going to help me solve anything because whatever works for x and y will work, and there's an infinite amount. I was not able to predetermine a specific x. So basically, going down that route, while correct geometrically, algebraically is not going to be able to allow you to do the answer. So I have to kind of wash that idea and say I can't do it that way. What other options are left to me if I don't do opposite angles congruent? Look at your ways. So if you can't use opposite angles or congruent, what can you use if you have all four angles?
The two sides are supplementary.
Consecutive angles are supplementary. So that's how I would solve this. I would do 4x plus 13 plus 12x plus 7. And I'm going to add 12x and 4x and get 16x. And by the way, that's going to equal 180 because they're supplementary. I'm going to add 13 and 7 and get 20. And now I even only have one variable to worry about. So by doing these two angles, these two consecutive angles are supplementary, I'm able to solve for x. 16x is equal to 160. So what would x equal? 10. And then if I do these two consecutive angles, they both just have y's. So 3y minus 2 plus y plus 10 equal 180. And then my y's combined, y plus 3y is 4y, minus 2 plus 10 is plus 8. And then 4y is equal to 172, and y is equal to 43. So in this way, I was able to come up with solutions for x and y. Probably just to be careful, I would go back and plug it in. If I plug in 43 for y, what's 43 plus 10? What's 43 plus 10? 53. So angle H was 53. 4x plus 13 is 4 times 10, which is 40, plus 13, which is also 53. So yep, the two opposite angles match. If I do it the other way, they'll match as well. And then hopefully when I find the solution to this angle and this angle, when I add them together, they'll be supplementary. They'll equal 180, which they will. But I would go through and check all of that to make sure that you didn't make an arithmetic error. Everybody okay with that one? All right. So we've already talked about that. Let's look at this problem 2 right here. So if I tell you in this particular picture right here that this is 5 and this is 5, and this is 50 and this is 130, can you tell me whether or not this is a parallelogram? And if so, can you identify the reason that would say, yes, it is?
Because those two sides are supplementary.
Sides can't be supplementary?
The angles.
Okay, so angle A and angle D are supplementary? And they're consecutive. So one of the rules was if you have consecutive angles that are supplementary, you have a parallelogram. So yep, I can definitely tell that's a parallelogram. What about B?
No.
Not only do I not have enough information to tell that it's a parallelogram, I can tell you it's not a parallelogram. Because if this is not the same as this, there's no way it can be a parallelogram. So none of the 6 work for this. All right. So that's just like the really, yes, sir.
So if, say like all 4 of those sides were congruent, would that be a parallelogram?
Yeah, because then both pairs of opposite sides would be congruent.
Okay.
So that meets one of our rules. And technically, there's a figure called a rhombus, and a rhombus is a parallelogram.
And it's all equal.
And rhombuses are all equal. All right, so see what you guys can do with these two. And you might have to dig a little bit deeper than just the surface stuff that's immediately available. All right, so what about part A here? Is that a parallelogram? Why? And what does reason 6 say?
One pair of opposite sides is congruent and parallel.
And so you see one pair of opposite sides that are both congruent and parallel? I see a pair of opposite sides that are congruent. I see a different pair of opposite sides that are parallel. That is not that reason. Yes? Yeah, I would say the answer is no. Did you have something different? What were you thinking?
I'm really lost, but I put reason number 3 of both pairs of opposite angles are congruent. 'Cause
Okay.
if the sides are congruent, then the opposite angles have to be right.
No. So, if these lines are parallel but have different length, these opposite angles are not going to wind up being the same. So, there are certain things that you can assume, like if you have a linear pair, you can assume those angles are supplementary. If you have vertical angles, you can assume that the vertical angles are equal. You can't look at a picture and just say the opposite angles are equal because they kind of look close to it. So be careful about that. So that's no, we can't determine that. What about this one? I actually marked this one up and I didn't mean to. So this one is a yes, and the reason is that side ends up being parallel to that side. Why?
Because the alternate interior angles.
Right. Alternate interior angles are congruent, makes the lines parallel. For the same reason, alternate interior angles make those lines parallel. Therefore, you have a definition of what a parallelogram is, where both pairs of opposite sides are parallel. So, I would definitely make note cards for each one of these things and look through them because they're not on your formula sheet and you're going to need to know them. So if tomorrow's bell ringer says, name the 6 ways to prove a quadrilateral is a parallelogram, you guys should get that right. And there's your homework.